Okay, so what I'd like to do right now is a database that will keep track of client transactions whenever they buy some products. So this is a classic design, but I would like to see and investigate the product development lifecycle for this until we come up with an actual database. We're going to use eventually Microsoft Access. Time permitting, I'll do another video with Oracle as well. So let's get going. Let's say we have a client. Here he is. And this client wants to buy a whole bunch of products. Okay, so we have products here. So these are all instances of products, right? So here's the client, wants to buy maybe 2 or 3 of these, maybe 1, and so on and so forth. So what's going to happen is for this purchase to happen, you have to have an event of some form, right? So this event could be your transaction. And within that event, you will associate the client to that event. And then you will associate, well, let's say these 2 products to that event. Since it is an event, you might want to also put maybe a date and time when that actual transaction happened. Okay? So that's typically how you would start the modeling and start thinking about, okay, how does this work? And then you move from there and you start actually using some modeling tools to come up with what we call an ERD, or an entity relationship diagram, okay? So this is a rough idea. Like, let's say you have a napkin and that's what you're doing, and you wanted to build a database and you have some idea on how to track these things. And that's typically how you would go about it, okay? All right, so let's move on to the next level, which is we will try to attempt to create an ERD. So how does that work? Well, these are instances. That means these are actual objects that exist, okay? But they're based on some form of a plan. What is a product? What defines a product, right? Same thing. This is an instance of a client. But what defines a client? So we would like an entity that represents the components of a client. So what could that be? Maybe client ID here that makes sure that your client is unique. Maybe a first name that identifies the client's attributes, like last name. Okay. All right. How about the product? Well, the product also is probably modeled out of an entity as well. And we're going to call this entity here client. Okay. And this entity here, we're going to call it product without the S. Now, since products are instances of product as an entity, so what could that have? Product ID. Or it could be a VIN number, or it could be any unique identifier that identifies a product. So product name, maybe a description, maybe a price, or a unit price maybe on that product, something like that. Okay? You could expand this and say quantity on hand. How much of that product do you have? Okay? That's if it's a group of products that are all identified as this. Like, let's say milk. Well, you only sell one kind of milk, so it has a specific ID. And then you could say, okay, I have 15 gallons of this, or something of that nature, and the price per gallon, this is what you would do here, okay? If you're selling vehicles, on the other hand, and this happens to be a VIN number, then quantity on hands will not make sense, because that is the whole thing here represents that vehicle, right? And in itself is one entity. So you have to be really careful as to what these attributes relationship with the actual entity is, right? So that's when you get into another concept later on in terms of evaluating the dependency of these attributes to the entity or the attribute to other attributes. Okay, that's called normalization. So that's a process in which you're going to streamline your entities here to have just the right amount of attributes to describe that entity as efficiently as possible. And then what's going to happen is you're going to now use some sort of a relationship between entities to make your model complete. So, but what's going to enforce these relationships? What's going to make them happen? Well, first of all, we've already established that a client is associated to an event. So there is a relationship between a client and an event. So our products. So how's that going to happen? Well, what an event, I did mention that there is a date and time for an event, but who were involved in the event? Well, I could have a representative of the client right here and right here that says this event belongs to this client. Well, fantastic. How about the product? Same thing. I could have a product ID here. Also, that happens to be a unique key right here in the product table, but it's now a referenced here as part of the event. Okay? So that leads us to another situation. So if these are identifiers that are unique, like client ID and product ID, to the entity's client and product respectively, what are they for the event? Well, we have two situations here. If that is the only type of purchase and the only time you're going to be this client buying this product ID, then you can combine these together and make them a composite, what we call a composite key for this particular event, which means that same client cannot later on buy the same product. Well, that's not feasible. Now, there are designs that require that you create a composite key of this manner. What if I had an event ID in itself? Yeah, that's fine. So this could be the unique item. And now you're no longer tied up to having these two together as a unique combination. Okay? So that's another design issue you have to tackle as you move forward. Okay, so what I'm going to do is, for my design, I am going to have the event ID, the unique key or the unique identifier for any event instance. Now, notice here I'm making a circle, just like these guys are instances of the entity. So the event as an entity, okay, will have an event ID, will have a client ID, will have a product ID, will have a date when the event happened, maybe date and time. How about other things? Like how much of that product did you buy? Quantity purchased, maybe. Quantity purchased of that particular product, right? So what can happen is, based on this quantity purchased, you could subtract it from quantity on hand and hence have a good inventory control database, which means that you could query the database later on to find out, hey, am I low on this product now? After a few transactions, do I need to reorder? Okay. So that's sometimes the main objective of some of these databases is to track your inventory, right? So this is a case where you could assign a quantity purchased for that particular case, where you can subtract it from quantity on hand and track now your inventory levels. Okay. All right. So how are these entities going to be related? And this is where the ERD, or entity relationship diagram, comes into play. So let me go ahead and create a new. So let's create the entity client right here. Next, I'm going to call that event transaction. Okay. Then I'm going to have product. Okay. So a client will be related to transaction in one way or the other. And in what manner? Well, you cannot have a transaction without a client. But a client may or may not have any transactions. That is usually referred to as a one-to-many. So M stands for many relationship. So N1, this is one. So we have a one-to-many relationship between client and transaction. How about the product? Same thing. Your product. You cannot have a transaction without a product. So technically speaking, you have also a one-to-many here relationship between product and transaction. Okay? So what's the relationship between product and client? Well, indirectly, what we have here is a many-to-many through the transaction table. So that is a many-to-many relationship. A client can have many products. A products can have many clients, right? But this is done through a third entity right here called a transaction. Okay? So there is no way to create what we call a cardinality of a many-to-many, physically speaking, that is, between these two. But you could logically say that these two are related many-to-many. So notice these crawl feet here. This is what you would do in some other ERD standard diagram that shows the cardinality between these entities. So you could see the crawl feet here. So I'm keeping it with keywords like one, many, right? So why? Because I could have entities that could be one-to-one, right? So it's not everything is a one-to-many, right? So I could have one-to-one relationships, okay? So, but in our case, how about a many-to-many? Well, a many-to-many, physically, you're not going to do this. So if you're going to do many-to-many, yes, you could say logically that your clients have many products and products have many clients. But physically, we're going to find out we're not going to be able to do this unless you have a third table. So what you're going to have is a one-to-many here and a one-to-many here to create the effect of many-to-many. Okay, so I'm condensing a lot of concepts with these examples. Okay, so I hope this explains now the one-to-many and the many-to-many. Now, how about the one-to-one? How does that work? Typically, to implement this, and this can be implemented physically in a database, is if you have, let's say, what we call a primary key or an identifier that uniquely identifies this entity. Let's say this is client, okay? And we have a client ID, okay? Now, let's say the client, okay, has an office. Well, just one office. Well, that office, we could identify it by the client ID as well, since it's only one office. So the office is really an extension of the client entity. You're just splitting it and putting it in a separate entity. Now, what does that mean technically? That means if you had name here, you could have had the office number here. But you chose to have the office number here in a separate entity. So we will not do it here. Now, why is that? Because the office number does not necessarily represent a client. So it is an office. So it is more related to the office. But it belongs to the client. Well, that's fine. In that this relationship as a one-to-one. And the key here is now notice that both entities use the same unique identifier. Okay, so for the one-to-many, let's go back. So we have a client ID here. Well, here you have a transaction ID, but you will have a client ID here, and you're going to say, okay, well, what kind of field is that? What kind of attribute is that? If it is here a unique identifier, which we call a PK or a primary key, in here it will be called a foreign key. Same thing here if you have a product ID here. And this would be a PK, which is a primary key. Then you would have a product ID here as a foreign key. And we're going to do FK for a foreign key here. Okay? Good. So other attributes you're going to have here, maybe quantity purchased, Q purchased. Here will be the names, first name, last name. This here would be the product name, product description, unit price, things of that nature, okay? To describe. So each one of these will describe the entity. So are these. They are describing the entity client. Okay, and they're supported by their primary key. Okay, this is what we call a form of normalization that we will, in another video, see what is a 1NF, or first normal form, second normal form, third normal form, fourth normal form, Boyce-Codd, and so on. So there's tons of these that are rules that decide what do you need to have here. What do you need to have here? Okay, so that's another lecture all on its own, which these techniques here allow you to efficiently figure out, okay, what do I need here? And I used it here actually to decide that the office shouldn't be here, but it should be in another entity. Okay, so what I did is what we call normalized, or this is normalization. Right? So this is where you get first normal form, second normal form, third normal form, fourth normal form. Each one has a rule on how to move forward. So you cannot be, for example, a second normal form if you're not already a first normal form. So the progression to a normalization goes this way. You have to be in first normal form to become a second normal form, third normal form. You could stop there depending on your design. Or you can continue depending on your requirements for the design. Okay, so I hope this crash presentation, all right, gave you some ideas on how to do this. And for some of you, this is a review. And I hope you enjoyed this, because the next video what I'm going to do is actually build this database. Thank you.